Today we will talk about a program for finding all real roots of a quadratic equation. So a quadratic equation is of this form: ax square plus bx plus c is equal to 0, where a, b and c are real numbers and x is our variable. So a quadratic equation and its roots depend upon the discriminant of a quadratic equation. So discriminant can be calculated with this formula: b square minus 4ac, where a, b, c are our real numbers as given above. So based on discriminant, we determine the roots. So if the discriminant is 0, both of its roots will be equal. If it is greater than 0, then both of its roots will be real and different. And in case of in case if it is less than 0, then its roots will be imaginary numbers. So this is the formula for calculating the roots of an equation. This is also known as quadratic formula. So this formula is of two parts. One variation of it is with the plus symbol here, and the other variation is with the negative symbol here, since you can't do both at once. So let's see how we implement it into a program. So first I have created an object of the scanner class. Then I have created three integers, a, b, c, which will be our main variables. And I have also created discriminant as an integer, since this equation will always produce an integer value as long as a, b, c are integers. For roots, I am using a double value, since a division is going on here. So as you know, a division can produce either integers or decimal values, so we are not sure. So that's why I am using the double variable, since it can hold both integer and decimal values. Next, I am inputting the value of a, b and c from the user, which you are already familiar with. In the next step, I am calculating the discriminant here. Here I am calculating the discriminant, b square minus 4ac. As you know, square, it can also be calculated by this formula: math.power. This is a math class. We are using functions of math class. So math is a class in Java which has several functions like sine, cosine, square root, tangent, absolute. All these functions are used to perform several mathematical operations. So as you can see, all these functions are available of the math class. So we can use the power function for calculating the power. So we have to input power, then we have to give it two numbers. In this case, our variables or our base and exponent are same. That's why I'm using b in both places. Think of it like an input to a function. So the first variable will be the base, and the second variable will be the power. So I can it's giving an error. So it can so its default argument is double. So to convert them into double, you can simply cast them into double. So this is how you calculate power. Remember, the first argument is the base and second is the exponent. Since here we are doing a simple square, that's why I multiplied them instead of using this power function, but you can use them if required. So then I am calculating 4ac, and then I am subtracting them. As you know, parentheses are very important. If we don't include parentheses, then this this whole equation will produce a different result, since we have to take care of the order of the evaluation. So we put parentheses, so we make our program go the way we want it to go. So next, I am using the quadratic formula. As you can see, first I'm using with the plus variation, and secondly I am using it with the negative variation. So these are both variations. So let's look at it here. So first time I have wrote mine negative b, then I'm using the plus sign, then I'm using math dot square root. It calculates the square root of any number. For example, if you want to calculate the square root of 5, you will pass it like this. Like this is how you calculate square root. You pass the value of 5 into the square root function. Since here I need to pass this whole equation, as you can see, I need to pass this whole equation into the square root. That's why I have written this b square minus 4ac formula into these parentheses, and it is the argument of this math dot square root function. So I have included parentheses into, and I have written b square into it. Then I'm subtracting 4ac as above. Then I am enclosing this with the parentheses. As you can see, this parentheses is parentheses start here and it ends here. My next parenthesis is linked to with this parenthesis, which is with the negative b. So this parenthesis is connected with this one, and the last parenthesis, it is linked with this one. So this with this, and the last one with this one. So that's how these brackets are linked. Then I am dividing the result of this whole expression by 2 multiplied by a, and it is exactly what we wrote here. So similarly, I am calculating the second root using the same formula. Okay, now we have calculated the roots. Now the next step is to find the roots. So in the first case, if discriminant is 0, then both of its roots will be equal. You can print either R1 or R2. Both will be equal. Else, if discriminant is greater than 0, in that case, we need to print both of its roots as they will always be different. But in the else case where discriminant is negative, else covers all other cases excluding if else case. So we have covered the 0 case, we have covered the greater than 0 uh, 0 case. So the only case that is left is less than 0. This is the only case that's left. But we can simply write else instead of adding another else if, since it covers the whole thing, all other cases which are negative values. So this was the program. Let's try running it once. So now it is asking for a value of a. Let's give it 1. Then it is asking for b. Let's give it -6, and for c let's give it 5. You can give any values. So as you can see, this is the case that is being executed since discriminant is greater than 0. So both of its roots are getting printed here. So that's it for today's video. Thank you.